All right, this is the final video, part 4, in reviewing Unit 1 for the Unit 1 test. So the last thing we did was talked about what we called other types of equations, which really fell into 3 different categories. We had these rational equations with variables in the denominator, and then we had the square root or root equations where you have variables under a root, and then or equations with radicals, and then we had equations that looked pretty ugly, but by doing a u substitution we could put it in quadratic form. All right, so let's start with the rational equations. So let me come up with an example and we can go from there. And then we can talk about the steps to solving these types of problems. So if we have here, let's start with, let me say, -3 over 2 minus x plus 1 over x plus 1 equals 3 over x squared minus x minus 2. By the way, feel free to pause the video if you want to try this on your own first. All right, first step, we got to factor the denominators because in order to solve for x, I want to clear the denominators. So I notice here that this can factor to x minus 2, x plus 1. And it's nice to see there's an x plus 1 here as well. Well, this one looks similar, but not quite like x minus 2. The good news is we can make it x minus 2 by multiplying that fraction by -1 over -1. In doing so, let's rewrite what we have. We have 3 over x minus 2 plus 1 over x plus 1 equals 3 over x minus 2, x plus 1. All right, so now we're going to clear the denominators by multiplying by the least common denominator, which happens to work out nicely here, x minus 2, x plus 1. And this means I'm multiplying both sides by this product. And if done correctly, my denominator, I should no longer have variables in the denominator. So multiplying by the first term, 3 over x minus 2, the x minus 2 goes away, and I get 3 times x plus 1. For the second term, the x plus 1 goes away, so I have 1 times x minus 2. And very nicely, when I do the last one, the denominator completely goes away, so I just have equals 3. All right, so now let's solve this here. I've got, let's see, we've got 3x plus 3 plus x minus 2 equals 3, or 4x plus 1 equals 3. I've got 4x equals 2, or x is 1/2. Now, once you get this answer here, you just want to double check that it wouldn't make your denominator 0, because that would be a problem, and then you would not have a solution. Or if it was just one of the solutions, that would not be part of it. Okay, but I'm looking, and putting in 1/2 will not make any of the denominators 0, so I am good there, as long as I didn't make a careless mistake. Okay, so if you have time, you can always plug it back in for x and make sure that it makes the equation true. All right, let's try second type here. So number 2, radical equations. All right, so let me think of something here. Let's do square root of x minus square root of x minus 12 equals 2. Now, in order to solve for x, I need to get them out of these square roots. So, and I can't, unfortunately, because there's 2 different terms that have square roots with variables under them, I can't do that in just one step. So I've got to isolate a square root to start. So I'll just bring the square root of x minus 12 to the other side. Now, when I square both sides, the root x, that x comes out. However, on the right side, it's a binomial that I'm multiplying by a binomial, so I'm going to be foiling this out. So I've got 4 plus 4 square root of x minus 12, those middle terms combined, plus x minus 12. So I've still got a square root, but not 2 at least. So now you're going to combine like terms. So it looks like the x's are going away. If I bring the 12 over, so 4 minus 12 is negative 8. So I'm going to bring the 8 over. Okay, and then let's simplify that by dividing both sides by 4. So 2 equals square root of x minus 12. Now I'm going to square both sides yet again. And I get 4 equals x minus 12, or x equals 16. Now, remember, when you square both sides, you're essentially making things positive. Think about if you squared like negative 2. So your solutions are solutions to the squared equation, but may not be solutions to the original. So you've always got to check for extraneous solutions. And to check, I'm literally going to plug it back into the original and see if it makes the equation true. So I've got square root of 16 minus, if I plug in 16 for x, I'd get square root of 4. Does that equal 2? This is my check. So 4 minus 2, in fact, does equal 2. So this is a solution. All right. Almost done. Last type we're going to do are U substitution. And how do I spot when I'm going to use a U substitution? Well, usually the rule is you've got 3 terms. 2 of them have variable components, and the other one doesn't. And those variable components are similar but kind of ugly with their exponents. And sometimes, by the way, there's maybe not 3 terms, but somehow like the exponents are looking pretty icky, and I want to make this look simpler. So let me see a good one to do here. Let's do this one. Let's do x to the negative 2/3 plus x to the 1/3, negative 1/3, sorry, minus 6 equals 0. So this is one where, okay, 3 terms. One of them is a constant and the others have variables, but so there's no GCF of all 3 terms that I can take out here. And these variables are looking, these exponents aren't looking pretty. So yes, let's do a U substitution. And sometimes people are like, well, I don't know which one to be U. Do trial and error. There's only 2 to check. And how you check is, let's make one of them U. So if I make U x to the negative 1/3, it should be the case, if I've done it correctly, that when I square what I made U, I should cover the other variable term. In other words, I should get x to the negative 2/3, because I want to rewrite all the variables in terms of U. And so if I square x to the negative 1/3, I'm getting x to the negative 2/3, which is perfect. So now, because if I had started with x to the negative 2/3 as U, if I squared it, I'd get x to the negative 4/3, which is not helping me with x to the negative 1/3. All right, so I've got my U right. So let's rewrite plus U, this original equation in terms of U. And it factors nicely, U plus 3, U minus 2. All right, and so U is either negative 3 or U is 2. All right, and sometimes the hard part now is, okay, let's go back and solve for x. So I plug back in what U was. And I like to do this in 2 steps for each of them. So I have x to the negative 1/3 is negative 3, x to the negative 1/3 is 2, and I need to solve for x. So I'm going to deal with the negative first. Raise both sides to the negative 1. So I've got x to the 1/3 equals negative 1/3. And same here. Let's raise both sides to the negative 1. X to the 1/3 equals 1/2. Now, the 3 in the bottom just means the cube root. And the reason I'm mentioning this is if it had been an even root, like say to the 1/2, which would mean the square root of x, the square root of something cannot be negative, so you would have gotten no solution from that piece. But because we're talking about an odd root, it can result in a negative, so this is okay, both solutions. Now, to solve for x, I'm just going to raise both sides to the third power. So I've got x equals negative 1 over 27. And in this other case, I've got x equals 1/8. And that's it there. Again, just be careful if it's an even root, that cannot produce a negative. So that's just something, I think on the hodgepodge we encountered that. So that's just something to be wary of. Okay, and so there you have it. Those are your topics.